Hi everyone. Now we are going to discuss about the topic autoencoders, which is one of the fundamental concepts in deep learning. So autoencoders are neural networks that learn to represent data efficiently by compressing the input and then reconstructing it. They are widely used in applications such as data compression, image denoising, anomaly detection, and feature extraction. Let's begin by understanding what an autoencoder is. So what is an autoencoder? An autoencoder is also called a AE. It is an unsupervised neural network that learns efficient representations of data without requiring labeled examples. It consists of two important components. The first component is the encoder, which compresses the input data into a lower dimensional representation known as the latent vector, or you can say the latent space. The second component is the decoder, which reconstructs the original input from this compressed representation. So the primary objective of an autoencoder is to reproduce the input as accurately as possible while learning meaningful features. Autoencoder architecture. So in this slide it illustrates the architecture of an autoencoder. The process begins with the input data. The encoder gradually compresses the information into a compact representation called the latent space. The decoder then expands this latent representation to reconstruct the original input. During training, the network compares the reconstructed output with the original input and calculates the reconstruction error. The model continuously updates its parameters to minimize this error, allowing it to learn compact and informative representations. Working of an autoencoder. Let's understand the working process step by step. First, the input data is provided to the encoder. Next, the encoder extracts the most important information and compresses it into a latent vector. Then this compressed representation is passed to the decoder. The decoder reconstructs the original input from the latent vector. Finally, the reconstructed output is compared with the original input. The difference between them is called the reconstruction error. The network is trained repeatedly until this reconstruction error becomes as small as possible. Applications of autoencoders. Autoencoders have many practical applications in artificial intelligence and machine learning. The first application is dimensionality reduction, where high dimensional data is converted into fewer dimensions while preserving important information. The second application is data compression, which reduces storage requirements. Another important application is image denoising, where noise is removed from corrupted images. Autoencoders are widely used for anomaly detection, where unusual patterns or defective data are identified. Finally, they are used for feature extraction, where meaningful features are automatically learned for classification and prediction tasks. Advantages and limitations. Like every machine learning model, autoencoders have both advantages and also limitations. Some of the major advantages are they automatically learn compact representation of data. They effectively reduce dimensionality without manual feature engineering. They are also very useful as pre-processing step before applying other machine learning algorithms. However, there are some limitations. Traditional autoencoders cannot generate completely new realistic samples as effectively as models like variational autoencoders or generative or adversarial networks. Another limitation is that the latent space may not always be structured, making interpretation and generation difficult. The concepts presented in this presentation are based on the following references. Textbook David Foster, Generative Deep Learning Teaching Machines to Paint, Write, Compose and Play, 2nd edition, O'Reilly Media, 2023. Thank you for your attention.